All right, here we have section 8.3, which is the special right triangles. So there are two special right triangles, the 45, 45, 90, and the 30, 60, 90. So we will start with the 45, 45, 90s. So in a 45, 45, 90 triangle, the length of the hypotenuse is root 2 times the length of the leg. So what that boils down to is if you have a right triangle, these two are congruent, these are both 45. If you are going from a leg to the hypotenuse, you multiply by root 2. If you're going from the hypotenuse back to the leg, you divide by root 2. It's as simple as that. So number one, assume the lengths of one of the legs in the 45, 40, 90 triangles is 4 inches. What's the total length of the diagonal? So I need to find what the length of one diagonal is and then multiply by 4 to get the whole length. So what I'm looking at is one of these triangles has a distance of 4 there. So to get to the hypotenuse, I have to multiply by root 2. So the diagonal is equal to 4 root 2. Now that's a fine number. That's an answer. You don't have to make that a decimal. So the total distance is 4 times that number. These are just 4 triangles. 4 times 4 is 16, root 2. And that's the answer. If you want the decimal equivalent, 16 times, whoops, root 2, you should have about 22.6 inches as your units. All right. So this one is just more of a standard triangle. So find the length of x, which is the leg. So I know the hypotenuse. So to go from hypotenuse to leg, I divide by root 2. So 6 divided by root 2 is actually 3 square root 2. Or if you go on your calculator, 3 root 2 is about 4.2. That's your answer. If you want to leave the radical, when you divide by root 2, you divide that number in half, and then you get a root 2 at the end. All right, for the other kind, 30, 60, 90, everything is based off the short leg. So the hypotenuse is twice the shorter length, and the longer leg is root 3 times the shorter leg. So draw my little triangle here. So 30, 60, 90. So to go from the short leg to the long leg, you multiply by root 3. To go the other way, you divide by root 3. To go from the short leg to the hypotenuse, you multiply by 2. To go the other way, you divide by root 2. So if you reverse the arrow, you just reverse the operation. Okay, so here, given BC is 14, find AC. So I actually need to do this in 2 steps. I need to go from BC to AB. So that's hypotenuse to short leg, so that's divide by 2, so that makes this 7. Then to go from the short leg to the long leg, and multiply by root 3, which makes this 7 root 3. So AC is equal to 7 root 3, which is about 12.1. Down here, we're going the other way, which I'll have to redraw this triangle because I used it up before. So BAC, right angle, 60. So in this case, it gives me the long leg. So to get to the short leg, I divide by root 3. So 8 divided by root 3 is going to be 4.6. And then to go that way, I multiply by 2. So BC is 9.2. The last one here wants you to graph. So triangle PCD is a 30, 60, 90. So I'll plot our points here. So C is at 1, 2, 3, 1, 2. Right there. D is at 4, 5, 6, 7, 8, 9, 2. So that's one of the sides of my triangle. So there's D, there's C. So that's the long leg, and the right angle is at C, which means that the other side either has to run up and down here or up and down below. It tells you here this in quadrant 1. This quadrant in the upper right is quadrant 1, so P has to be somewhere above C because there's going to be a right angle there. Locate point P in quadrant 1. So to do that, I need to figure out how far above C P is. To do that, I need the length of this leg. That leg is 6 spaces long, which means to get the short leg, I have to divide 6 by root 3, which is about 3.5. So I have to go up 3.5 from here. So there's 2, 3, 4, 5. So 1, 2, 3.5. B right there. So there's P. Looks like a D. Yeah. And it wants the coordinates. So this is the same distance over as C. So it's 3 spaces over. It's 3.5 above C. C was already at 2, so 3.5 more would be at 5.5. That's the end of the section.